Hello, I'm Jonathan Ehret from RWTH Aachen University, and it's my pleasure today to present to you our paper on evaluating the influence of phoneme-dependent dynamic speaker directivity of embodied conversational agent speech. That's quite a bulky title, so let me try to decompose that. So first of all, there's embodied conversational agents in there. And I'm quite sure that most of you are familiar with that concept. And for us, having audio and sound in virtual reality with virtual agents and embodied conversational agents, the most important part here is the embodiment part, so that we actually know where the agent is. So the agent has a position, and we can actually hear that position. So what we add now on top is phoneme-dependent speaker directivity. So directivity in general means that we can also hear not only where the agent is, but also where the agent looks, which might be important. I will present two different degrees of realism of this directivity organization. But I'll just start with the, let's call it default case. So what's normally done in VR, so that you have an agent which speaks in an omnidirectional fashion. So there is no change of the speech when the agent turns away from you. So I'll show you a short clip and pay special attention for the situation when the agent actually talks away from you.
Beat, bit, bait, bat.
Okay, so you don't hear anything, so you can't hear the rotation. So what we now add on top is directionality. That means that the sound is not distributed in all directions the same, but more focused to the front and dampened in the back, as it is in reality. So that sounds like this, and again, pay special attention to the back.
Beat, bit, bait, bat. Bat.
Okay, so you can hear it and perceive that it's more muffled in the back, actually. So what we now added on top of that is, we call it dynamic or phoneme-dependent directivity. That means that the content of the speech the agent produces also has an influence on the directivity. So if I make an R, I have a different radiation pattern than if I make an E, for example, which has a very different shape of my mouth and vocal tract. And now if we add this phoneme dependency on top, that sounds like this.
Beat, bit, bait, bat, bat.
Okay. So did you spot the difference? And that's actually one of our motivational questions. So is it distinguishable at all? Are differences between these organizations distinguishable? So especially between the dynamic and the static directivity, so the phoneme dependent and the non-phoneme dependent, which is always the same. But also whether the difference between the omnidirectional and this directional sound is distinguishable, which you probably already heard that it is. Then more questions that motivated us to do this, this work were whether it is preferred to have directional sound, and whether this is perceived as more natural, which is physics-wise would be, but question whether people actually listen in to real talking situations that deeply that they understand that it's more realistic, or whether they think it sounds more artificial in some way. And then when thinking about designing a study for this, what also came up is whether the acoustical environment plays a role. So for example, if an agent is talking in a small room, then you have a lot of reflections, so acoustical reflections of the wall. So if the agent was talking away from you, the agent would be talking towards a wall, and that sound would be directly reflected back. So yeah, this effect of the directionality wouldn't be as strong as it is in a free field situation. So outdoor, where you don't have any reflections, and there you have a stronger effect if the agent is actually talking away from you, because then you only hear this indirect sound, which is then more muffled. So from these motivational questions, we derived the following hypothesis. First, we expect that the naturalism, so how participants rate the naturalism of these oralizations, is the least high for omnidirectional, and for static and dynamic directivity it should be higher, and approximately equal. We also expect people to prefer the oralizations which they feel are more natural. Then we think that natural differences should be stronger in free field, and we hypothesize that static and dynamic directivity are distinguishable if we give full control to the participants to actually listen to exactly the things they want to hear and try to distinguish those. So from these hypotheses, we derived the following study design. So we thought a good thing would be to have our agent being a tour guide, in this case for us in the Somerset House in London. So here you can see a courtyard of the Somerset House, which was our outdoor situation because all walls are so far away that you can approximate it as a free field situation. And then we designed also a museum room, which is inside the Somerset House. So you can see it outside the windows, and there are pictures and details of the Somerset House set up so that the agent could give the exactly same speech with the same movements in both settings. And this room is exactly the size of our cave so that people could walk around freely. And then we had participants change the oralizations, so between omni, static, and dynamic directivity. And they could do that by switching buttons all the time in between while the agent is speaking. And a signpost next to the agent always showed which variant was playing, but only naming them variant A, B, C. And the mapping of these variants to the oralization is randomized. So let me show you a short clip of this. And here you can see the actual interaction device our participants used in the cave, so a fly stick. And with these 3 buttons, participants were able to switch between the variants, which was shown here. And now it's also shown here for you to understand what's happening. And I'll always show a red cross if a click would be made by the participants.
The Somerset House was initially built to house governmental offices. Today, it is an arts and cultural centre, housing concerts, exhibitions, films, and workshops year-round. The architecture of the building reflects a neoclassical style.
Now you'll see them.
This style is all about symmetry, evident in the repetition of form and similarity of lines. We see even-spaced windows, repeating brick facade patterns, etc.
Okay, so that talk is only a small fraction, lasted 90 seconds, and afterwards, and was repeated 3 times per setting. And afterwards, each time there was a questionnaire displayed asking which variant you preferred and how natural each of these oralizations was rated. And if people weren't sure after hearing the 90-second speech once, they could also click repeat and then listen in again and save all the answers they gave so far. What a lot of people did once, but then after having 1 repetition, all participants were able to actually decide on these numbers. And then we added also a second part, an ABX comparison, which was repeated 3 times per pair of oralization. And ABX comparison in this case works like this. We have 3 agents. Agent A has 1 oralization and agent B has another oralization. And agent X always has either the oralization of A or B, and participants could listen into each of them as long as they wanted, and they were rotating while listening and having these word sequence you heard before, which featured vowels, all the vowels, so that the differences between these directivities could be audible. And then they had to decide which one was equal. So here's also a short video.
Beat. Bit.
Maybe try to also do it.
Bait. Beat. Bit. Bait, beat, bit, bait.
Okay, this one was maybe easy. So they had to click now the leftmost button for X equals A and the rightmost for X equals B. And in this case, X equals A, as you probably have heard. So then clicking the leftmost button would be the correct answer. Okay, so that's our general study design. And the second part was always done last to not prime participants on the differences they might have heard. However, before executing the study, we first had to create the needed directivities, so these directional filters, and there are two general approaches to do this, either by recording somebody playing an instrument, or in our case, a speaker, with a lot of microphones, and then doing computation to generate these filters, which is very time consuming and also very costly, or you could do a simulation, which we did. So a boundary element method was used in our case. And this is a vocal tract of a human, so the throat and the inner mouth and the mouth opening. And to our help, there is also work on this by, for example, Takayuki Arai, who found out that you can simplify this very complex vocal tract by a radial symmetric tube. And then we put this radial symmetric tube into a virtual head model to simulate how sound is radiated. With different tubes for different vowels. So that will look, for example, like this. So these are two examples. And in total, we did 4 simulations for 4 different vowels on this chart of the International Phonetic Alphabet, on the vowel chart, going from close mouth opening to open vowels, and also from frontal vowels to vowels which are more produced in the back of your mouth. And actually looking at the data, we saw that this dimension doesn't play a big role in the differences of the generated filters. So we ended up just using these 3 directivities, and then we switched them during speech based on the content of the current speech. So here are the results of our simulated filters. So you can see it for an A, for different frequencies, and you can see that it's always more pronounced to the front than it's to the back, at least in these high frequencies. In the lower frequencies, it's nearly omnidirectional. That yields this muffled sound in the back. And what's also interesting here to see, so this is the mean modulation, so the amplification or reduction of the sound depending on the frequencies. And this mid blue shaded area is actually the standard deviation between the different directions. So you can see that there's a lot happening between the different directions. So this is very well audible. So 1 decibel is the perceptual threshold here, the theoretical. And here the darker blue shaded area is actually the standard deviation between the different vowels. And you can see that it only starts to show up at all for above 4 kilohertz, and speech goes up to 5 kilohertz. So we already saw that this might not be distinguishable by our participants. Okay, then we conducted the study with 32 participants, 9 female, with a mean age of 28 years in our cave, using the acoustical system and the ceiling of our cave for dynamic crosstalk cancellation. Unfortunately, we finished the study right before the lockdown, so I can't show you any more polished videos of how the interaction worked in the actual environment, but I hope the videos I showed before give you a feeling of what we actually did. So looking at the results and our hypothesis we had before, these are the results for the AVX comparison. And we can see that comparing omnidirectional versus either dynamic or static directivity, participants were well able to distinguish it nearly with 100%. Correct? Yeah, and this is statistically significant compared to 50% mere guessing, and between static and dynamic, yeah, it's nearly 50%, so participants were nearly guessing. So we actually have to reject the hypothesis that static and dynamic directivity are distinguishable. Looking then at the naturalism ratings, for the indoor and outdoor case and for all 3 organizations, we also unfortunately did not see any significant differences between these naturalisms compared between the different scenarios. So we have to reject that it's stronger in free field. And we did not see a significant difference in naturalism between either. So we unfortunately also have to reject that hypothesis for now. However, looking more into what people answered on the questionnaire, so what they actually preferred and how they rated them, we saw that participants always rated so they preferred omnidirection, so they said variant A is the best, and then how they rated the naturalism of variant A is always significantly higher than that of the other 2, and that's the same for all 3 organizations. So actually participants preferred what they deemed most natural, so we can accept that hypothesis. And looking at that preference in more detail, we also looked at how often, so there were 6 trials in total, and how often participants preferred static or dynamic directivities, whereas omnidirectional. So in this case here, there were 4 participants who always preferred the directional sound, and there were 5 participants who 5 of 6 times preferred the omnidirectional sound. So we saw that there is a split. And looking at the naturalism data with regard to that, we saw that they again rated the one they preferred higher, but there's still no difference in static versus dynamic directivity. So, and also it's not distinguishable. So we are quite confident that the naturalism of these is similar. So we cautiously accept that hypothesis. Okay, that already brings me to the takeaway message. So first of all, dynamic directivity might not be needed for speech. So that means that probably you don't have to care and you can just use static directivity, which is nice because you don't have to have a link between the animation system and the audio system, which saves you a lot of work. Furthermore, the preference for directional speech seems to be very subjective, and we hypothesized further that this might be due to speech perception. So whether you are able to understand the speech, because that worsens when you turn away. I'm nearly done, sorry.
Excuse me, Jonathan.
Yeah.
I'm sorry to interrupt. You are around 16 minutes and a half. If you can sum it up, please.
Yeah, totally.
Thank you very much.
I'm right on that.
Interrupt.
No worries. Yeah, that might be less realistic or perceived as less perceptual, and therefore they didn't like the directional case. But participants preferred speech which they deemed more natural. So thriving for higher naturalism is a good thing and worth doing. So thank you for your attention, and if there are any questions, I would be happy to answer those. I will try to answer